Today, we're going to tackle a math concept that can seem kind of tricky at first, linear functions. But trust me, by the end of this, you're going to get it. In fact, you'll start seeing it everywhere you look.
Okay, let's just dive right in with a question. You ever get in a taxi and just watch that meter tick up and up? Have you ever actually wondered what's going on behind those numbers? It's like a little puzzle. And the answer? Well, it's the key to this whole thing. So let's start right there with our taxi ride puzzle. We're going to break down that fare into two really simple parts.
Okay, so anytime you take a cab, the total price is really just two things. First up, you've got the base fee. That's the flat price you pay just for opening the door and getting in, before the car even moves an inch. Then there's the per mile cost. For every single mile you travel, the meter adds on the exact same amount of money.
So it all boils down to this one simple idea. You have a starting point, that's our base fee, and then you have a steady, predictable change, that's our cost per mile. If you get that, you've basically just unlocked the entire secret behind linear functions. It's really that straightforward.
All right, now let's see how this whole taxi ride thing connects to the math you see in your textbook. We're going to link our little story directly to that famous formula that everyone talks about.
And here it is. Y equals mx plus b. Now I know, it looks a little intimidating with all the letters, but don't let it fool you. This is just the secret code, the recipe for what we just said, a starting point plus a steady change. Every single letter here has a job to do.
And check out how perfectly this all maps out. That letter B over on the end, that's your starting point, our base fee. The M is that steady change, the cost per mile. It controls how steep the price goes up. X is just the number of miles you drive, and Y? Well, Y is the grand total, the final fare you end up paying. See, each piece has its place.
And here's the coolest part. Anytime you have a situation that follows this recipe, it will always, and I mean always, create a perfectly straight line when you put it on a graph. That's why they call it linear. It's all about the line.
But, talking about it is one thing. Let's actually see it happen. We're going to take our taxi ride and turn it into a graph. Just watch how this straight line magically appears, step by step. Okay, so let's imagine our base fee, our B, is $3. Right at the beginning, at 0 miles, your cost is already $3. Boom, that's our very first dot on the graph. It's our starting point. Now let's say our steady change, our M, is $2 per mile. So after we travel 1 mile, what happens? We take our $3 starting point and we add that $2 change. Our new total is $5. Let's put that dot on the graph.
And after 2 miles, you got it. It's our $3 base fee plus $2 for the first mile and another $2 for the second mile. That brings our total to $7. We plot that third point, and you can already start to see it taking shape, can't you?
And now for the big reveal. When you connect those dots, what do you get? A perfect straight line, heading right on up. That constant, steady change of $2 a mile is exactly what makes the line so perfectly straight. It never curves, it never wobbles.
So our taxi fare line went uphill because the price was going up. But not all lines go up, right? So let's take a quick look at what makes a line go uphill versus downhill.
It all comes down to that M value, the steady change. If M is a positive number, like our plus $2 per mile, the total value is getting bigger, so the line goes uphill. Think of it like earning money at a job. But if M is a negative number, the total value is getting smaller, so the line goes downhill. That's like spending a gift card. The balance goes down with every purchase. It's that simple. Positive M goes up, negative M goes down.
Okay, so why does any of this matter? This is the really cool part. Because once you get this simple pattern down, you'll suddenly realize this isn't just some boring math class concept. This pattern is literally everywhere in the real world. No, seriously, think about it. Your phone plan? It probably has a starting base fee and then adds a steady cost for every gigabyte of data you use. Saving up money? The cash you have now is your start, and the amount you save each week is that steady change. This pattern describes everything from growing your playlist to how a business works. So look, if you only remember one thing from all this, let it be this. A linear function is not some big, scary, complicated idea. It's just a story, a simple story with two parts, a starting point and a steady change. If you can find those two things, you've found a linear function. End of story. So I'm going to leave you with a challenge. Now that you know what to look for, what other stories can you find out there that follow this same starting point plus steady change pattern? I promise you, once you start looking, you're going to see them everywhere.